Hi guys, this is the third problem that we are doing related to work, and I would like you to pause the video now and read the problem. Alright, so assuming you did that, I am going to read the problem again. We have F1 force, F2 force and F3 force all are given to us. And then you have the angle as 60, that is also given to us. And one other important information is also there, and that is the fact that the trunk is moving leftward 3 meters in the leftward direction, and the direction is given to us. So the question asks us, during the displacement, what is the net work done on the trunk by the three forces. Now, since we have the direction of the displacement given to us, this is a problem where we can use the method finding net work using the work done by each force. F1 and W done by F2 and the W done by F3. So to make our lives easier, I am going to draw the trunk and like a dot, and this is our F2 force, and it is making an angle 60 degrees with the x-axis here. I mean, x-axis is irrelevant here because all the forces are measured with the direction of motion, right? That's what we discussed in the class, especially when in dot product. And that is what we have, all the forces. And then the forces are given to us as 9 newtons, 3 newtons, and F1 equals to 5 newton. Now I am using a different color to show the displacement vector, the red. This is the direction that it is moving, so keep that in mind. Like last time, I am not going to complete the full problem, and I'm going to let you do that again. It will also replace another poorly done quiz problem. So the work done by F1, I'm going to do an example and show this. F1 d cosine theta. So the displacement is pointed in leftward direction, right? So we can substitute the values now. F1 here is 5 newtons, and I put 5 here, and the displacement is given to us as 3. So F5 times 3 times, and the angle between D and F1. So I am going to draw them separately here. This is our D and this is our F1. So they both are pointing in the same direction, meaning the angle between the two is 0. So the cosine 0 is 1, and the answer here is 15 joules, and that is our WF1. WF1 is 15 joules. Now I am going to let you work on the second and the third one. So I'm going to ask you to stop the video and find work done by force 2 and the work done by force 3. Now, assuming that you paused the video and completed the work, I can actually write it now. F2d cosine and the angle. So let me call this theta 2 here. And there you have F3d cosine. Let me call this theta as theta 3. So since I am going to grade this and replace one of the homeworks that the quizzes that you did bad, I'm not going to help you on this one, but just to let you know that you know F2, you know D, and you know theta 2. Now again, just to show that this is your D and this is your F2. So, and that's it, okay? Now, once you find the network, so let's find what is the network done on the trunk. So let me actually rewrite the equation. So W net is going to be work done by force 1. Now you have the answer there, 15 joules. I did that part for you. And then work done by force 2 and the work done by force 3. And you will get an answer, a numerical value here, and the unit is joules, right? And then the second part of the question asks us, does the kinetic energy of the trunk increase or decrease? Does the kinetic energy of the trunk increase or decrease? Now this is where I would like you to pay attention to the equation that we learned in the class, work energy theorem. Work energy theorem. In the work energy theorem, we learned that the network equals to kinetic energy final minus kinetic energy initial. Right? So this is the work energy theorem we learned in the class today. Now, if you have, depending on what you have for network, depending on the positiveness or the negativeness of the network, you should be able to answer whether the kinetic energy final is greater or less than the kinetic energy initial. Now, when you are answering part B, I would like you to think about the answer you got for W net. Even you can apply that. I mean, you can just substitute for W net and then you can argue about the kinetic energy final and kinetic energy initial, whether the one is greater than or less than the other, because the problem is asking you to find, does the kinetic energy of the trunk increase or decrease? So I am going to let you answer that question and I am going to end the video here.